Hello everyone and welcome back to my channel. With 2026 just around the corner, the DevOps landscape is evolving faster than ever. Today, we are breaking down the top 20 DevOps interview questions you need to master, updated with the latest trends. Now, before we get into the questions, you need to know what hiring managers are looking for in 2026. It's no longer just about CI/CD and Docker. So you will need to concentrate on platform engineering. So companies are building internal developer platforms to provide self-service capabilities. So DevOps is shifting from supporting teams to building the platform they use. Then you have AI and ML ops integration. So AI isn't just for applications, it's for the platform itself. AI ops for monitoring, predictive scaling, and automated incident response. Understanding ML ops pipelines is a huge plus. Then you have GitOps as standard. So using Git as a single source of truth for both infrastructure and application deployment is becoming the default, especially with tools like Argo CD and Flux. Then you have security shifts left and right. So DevSecOps is now non-negotiable. Security isn't just at the start, but also in production with runtime security and observability. And then finally, you have FinOps. So, cloud cost management is a core DevOps responsibility. You are expected to optimize resources and control spending. So, keep these in mind as we go through the questions. All right, let's get into it. So, here I have top 20 questions with a concise, high impact answers for each. First, let's start with the basic question. So, what is DevOps and how do you explain its core benefits? So, DevOps is simply a cultural and professional movement that combines the development and operations team to shorten the software development lifecycle and provide continuous delivery with high quality. Its core benefits are speed, which is faster releases, reliability, which is more stable systems through CI/CD and monitoring, and then finally, improved collaboration, which ultimately leads to better business outcomes. The next question we have is explain the concept of infrastructure as code and its advantages. So, IAC or infrastructure as code is a practice of managing and provisioning infrastructure through machine readable definition files rather than physical hardware configuration or interactive tools. Key advantages include consistency by eliminating manual errors, version control for your infrastructure, faster provisioning and disaster recovery as you can rebuild your entire infrastructure from code. The next question we have is what is the difference between Ansible, Terraform, and Kubernetes? Now, this is about their primary purpose. Now, we know that Terraform is an infrastructure as code tool used for provisioning cloud infrastructure like VMs, networks, and storage. Ansible is a configuration management tool used to configure that provisioned infrastructure, installing software, and managing settings. Kubernetes, on the other hand, is a container orchestration platform that automates the deployment, scaling, and management of containerized applications. They often work together in a pipeline. The next question we have is describe a typical CI/CD pipeline you have built or maintained. So, a typical pipeline starts with a code commit to a Git repository, which triggers a build stage where the application is compiled and a Docker image is built. This is followed by a test stage running unit and integration tests. If tests pass, the image is scanned for vulnerabilities and pushed to a registry. Finally, in the deploy stage, a tool like Argo CD or Jenkins applies the changes to a Kubernetes cluster, often with a canary or blue-green deployment strategy. The next question we have is what is GitOps and why is it gaining popularity? So GitOps is an operational framework that uses Git as the single source of truth for both application code as well as your infrastructure declarations. The desired state of the system is defined in Git, and an automated operator like Argo CD continuously reconciles the live state with the state defined in Git. It's popular because it provides strong audit trails, improved security through pull-based models, and easier rollbacks by simply reverting a Git commit. The next question we have is how do you manage secrets in a Kubernetes environment? So for this, we should avoid hard coding secrets in your YAML files. Instead, we can use a dedicated secrets management tool like HashiCorp Vault or Azure Key Vault or AWS Secrets Manager. In Kubernetes, we can use the Vault Agent Injector or Secret Store CSI driver to dynamically inject secrets as volumes or environment variables into pods at runtime, ensuring they are never stored in etcd in plain text. The next question we have is explain blue, green, and canary deployments. Now, both are strategies to reduce deployment risk. Blue-green involves having two identical environments. So we will essentially route all the user traffic to the blue environment running the old version, and then we will deploy the new version to the green environment, test it, and then switch all the traffic to green instantly. Rollback is just switching back. Canary deployment involves rolling out the new version to a small set of users first, monitoring its stability, and then gradually rolling it out to everyone, minimizing the blast service of a bad release. The next question we have is what is observability and how is it different from traditional monitoring? So traditional monitoring is about watching a set of predefined metrics and logs to known failures. Observability is a property of a system that allows you to understand its internal state by examining its outputs like logs, metrics, and traces. It's about exploring the unknown unknowns. When a novel error occurs, observability tools help you to ask new questions and drill down to the root cause without having pre-configured a dashboard for it. The next question we have is how would you troubleshoot a pod in Kubernetes that is in a crash loop back-off state? So for this, we can follow a systematic approach. First, we can run the kubectl describe pod and the pod name to see recent events. Then we can run the kubectl logs and the pod name -- previous to get the logs from the last crashed instance, which usually contains the application error. If that is not clear, then we can run the kubectl exec command into the pod before it crashes to inspect its file system or environment, or check if it's failing a liveness or readiness probe due to misconfiguration. The next question we have is what is FinOps and what is a DevOps engineer role in it? So FinOps is a cultural practice of bringing financial accountability to the variable spend model of the cloud. So as a DevOps engineer, the role is to be a cost optimizer. This includes right sizing resources, implementing auto scaling to avoid over provisioning, using spot instances for fault tolerant workloads, tagging resources for cost allocation, and regularly cleaning up unused assets like old EBS volumes or AMIs. The next question we have is what are Docker layers and why are they important? So a Docker image is built from a series of read-only layers. Each instruction in a Docker file creates a new layer and the layers are cached. So if I change one line in the Docker file, only that layer and the ones after it needs to be rebuilt. This makes subsequent builds much faster. To optimize, we can put the frequently changing instructions like copy at the end and stable ones like run apt-get update at the start. The next question we have is explain the sidecar pattern in Kubernetes. The sidecar pattern is a multi-container pod design where a helper container, usually the sidecar, extends or enhances the functionality of the main application container. They share the same lifecycle, network, and storage. A common example is a sidecar that handles log shipping, pulling logs from the application container, and then sending them to a central system like Elasticsearch, so the main app does not need that logic. The next question we have is what is shift left security? Shift left security is a practice of integrating security checks and tools early in the software development lifecycle, literally shifting it left on the project timeline. This includes having developers run SAST, which is your static application security testing tools in their IDEs, scanning for vulnerabilities in dependencies during the CI build, and checking IAC templates for misconfigurations before they are even deployed. The next question we have is how does a service mesh like Istio work? So a service mesh like Istio uses a data plane and a control plane. The data plane is made of lightweight proxies like Envoy deployed as sidecars to each pod. These proxies handle all the service-to-service communication, providing traffic management, security, and observability without changing the application code. The control plane configures and manages these proxies for us. The next question we have is describe a time you had a major production outage and what did you do? So we can structure the answer using the incident command framework. First, we will focus on identification and escalation, like checking alerts and then assembling the team. Then we will focus on communication, which is updating the respective stakeholders. Then we will work on the mitigation, like implementing a short-term fix, like rolling back the deployment to restore the service. Finally, after the incident, a blameless post-mortem to document the root cause and implement long-term fixes like adding a specific test or improving our canary analysis to prevent recurrence. The next question we have is what is the difference between a liveness and a readiness probe? So a liveness probe determines if a pod is healthy and running. If it fails, Kubernetes kills and restarts the pod. It answers is the application dead. A readiness probe determines if a pod is ready to accept traffic. If it fails, the pod is removed from the service's load balancer. This answers is the application busy or under load and shouldn't receive any new requests. The next question we have is how do you ensure your IAC is secure and compliant? So for this, we can integrate security scanning directly into the IAC workflow. Before any Terraform code is merged, we can use static analysis tools like Terrascan or checkov in the CI pipeline to scan for misconfigurations against policies like CIS benchmarks. For already deployed infrastructure, we can use tools like AWS config to continuously monitor for drift from our compliant baseline. The next question we have is what is MLOps and how does it relate to DevOps? So MLOps is DevOps for machine learning. It applies DevOps principles, CI/CD, version control, and monitoring into the machine learning lifecycle. The key differences are the components we manage. So beside code, we also manage data and models. And MLOps pipeline might include stages for data validation, model training, model evaluation, and model serving, all automated and reproducible. The next question we have is why might you choose a monorepo over multiple repositories? So a monorepo where multiple projects or services are stored in a single repository offers advantages like simpler dependency management. It's easier to make cross-cutting changes across services. It also provides better visibility and code reuse. The trade-offs are the need for powerful tooling to handle the repo size and more complex CI/CD pipelines to only build what has changed. The last question I have is what are your strategies for managing technical debt in a DevOps context? So for this, we need to believe in a proactive approach. First, track it explicitly by creating tickets for it. Second, allocate capacity for it, dedicating a small percentage of each sprint to bringing down the debts. Third is to automate wherever possible. So if the debt is in manual processes, script them. Finally, prevent new debt by incorporating code reviews, linters, and security scanners into every commit and pipeline. Now, knowing the answers is one thing, but avoiding common pitfalls is another. So here's what trips people up. Being too vague. Saying I use Jenkins isn't enough. Describe what you built, how you configured it, and what are the outcome was. And what the outcome was. Then not knowing the why. You can explain what a canary deployment is, but can you explain why would you choose it over a blue-green deployment? Understand the differences. Then you have ignoring soft skills. DevOps is about collaboration. When you describe an outage, focus on teamwork and communication, not just how you heroically fixed it. And then fumbling the basics. You might know Istio, but if you can't clearly explain the difference between a deployment and a stateful set, it's a red flag. And then finally, no demonstration of learning. When asked about a failure, the worst answer is I have never had one. Show that you learn from mistakes. And that brings us to the end of our session. Mastering these questions and concepts will put you in a fantastic position for your next DevOps interview in 2026. If you found this session helpful, smash that like button, subscribe to the channel for more content, and let me know in the comment section if you have any queries. Thank you for watching, and I will see you in the next session.